Hello everyone and welcome to this second video in the ongoing saga of NEET 150 plus target videos. So in these videos what we are going to do is we are going to target at least 150 plus marks out of 180 in physics in NEET 2024 examination. So if you are a NEET 2024 aspirant, these videos are for you. Okay, if you haven't watched the previous video, in the previous video we discussed the pattern of the questions, we discussed what chapters carry more weightage, what chapters carry less weightage, and we also looked at and outlined a plan of study. So I hope you are following that. Okay, so in that ongoing series, what I want to do today is I want to go over a few questions, first 25 questions out of NEET 2023 paper. Now we'll be strictly going over physics. Okay, first 25 questions, we'll see what kind of questions they ask, what chapters they're asking it from, and I'll also comment on the difficulty or ease of questions as they come along. Okay, so my name is Sandesh. Welcome to Diksha. Let's start. So let's look at the first question. This question says there's a wire suspended from a ceiling or any kind of a rigid support and it's stretched by a weight W attached to its free end. Alright, okay. The longitudinal stress at any point in the cross-sectional area A of the wire is. Okay, let's see. This is a rigid support and a weight W is suspended from it. Okay, so this is the wire we are talking about. In this wire, how do we calculate the stress generated? Well, there's a simple formula for stress. This shouldn't be very hard for you guys. Stress is force applied divided by area of cross section of the wire. So in this case, if the weight W is suspended from it, the force applied is going to be W, and the area of cross section as given in the question is A anyways. So W by A. See how easy that was. Option number 2 should be the correct answer for this question. Mechanical properties of solids, a very simple question from that topic. Alright, let's move on to the next question. Calculate the ratio of radius of gyration. Calculate ratio of radius of gyration for a solid sphere of mass m and radius r and radius of gyration of a hollow sphere of same mass and same radius. So basically you have two spheres. One is hollow, one is completely filled. Both have same mass, same radius. Calculate the ratio of their radius of gyration or gyration. So what is radius of gyration then? Moment of inertia I is equal to mk square. So sometimes you'll see G symbol used here. Basically means the same thing. This k here is the, what is it? It's the radius of gyration here, okay? So what this question asks you essentially is to find out ratio of these two for a hollow sphere and then for a solid sphere. So for a hollow sphere, or let's do the solid sphere first. For a solid sphere, what is radius of gyration? Well, what is the moment of inertia first of all? 2 by 5 mr square. That's for a solid sphere. And for a hollow sphere, the same thing is 2 by 3 mr square. Okay. Now these are formula based questions. You need to remember these formulas for moment of inertia. So if you don't, I suggest you go and revise these formulas, okay? So from here, if I equate this to mk square, you can clearly see radius of gyration, if things cancel out, and radius of gyration r1 comes, k1 comes out to be root of 2 by 5, and similarly k2 here comes out to be root of 2 by 3. Now if I take the ratio of solid to hollow, 2 by 5, root 2 by 5 to root 2 by 3, the ratio comes out to be root 2 cancels out, root 3 goes up, root 5 goes down in the new denominator, root 3 by root 5, and that should be my answer, option number 1. Now this was not very difficult. There was a little difficulty in this, and that was remembering these formulas. So I told you, questions will be formula based, questions will be a little difficult. You'll need to remember the formulas. Moving on. All right, a question from capacitors. Let's see what the question says. Equivalent capacitance of the system shown in the following circuit. Look at the circuit. What does it have? You have one capacitor of 3 microfarad, and then there's two more in parallel of same capacitance, 3 microfarad. So you have 3 capacitors, 2 in parallel, and the third one in series to the combination of the two. Okay. How do you calculate equivalent capacitance of two capacitors in parallel? You just add them, right? Equivalent capacitance in parallel is C1 plus C2. And what about in series? In series it is 1 by C1 plus 1 by C2, okay? It's the opposite of resistances, don't get confused, alright? So, for these two, I can just say the equivalent would be C1 plus C2, 3 plus 3, that's 6 and then 3. So all I have to do now is just calculate the equivalent of these two. In series, there's a direct formula for C equivalent, and that is C1 C2 by C1 plus C2. Simple stuff. 3 into 6 by 3 plus 6. If you do the calculation, that's 18 by 9 or 2 microfarad. That should be the answer. Let's check the option. Option number A or option number 1 should be the correct answer. Alright, moving on. This is a question from motion in plane. The question says there's a football player moving southward and he suddenly turns eastward. He's still moving with the same speed. So calculate the force that was acting on him when he took that sharp turn. Okay, so let's first of all map this out. Let's call this north. Let's call this east. Okay, so that we are all on the same page here. He's moving south and then he suddenly turns east. So he was moving like this initially. This was his U. And suddenly he took a turn like this. Okay, alright, good. So initially this was his momentum. Finally, this was his momentum. Okay, velocity is still the same, it's just the direction has changed. So how do you calculate the force acting? Well, force acting is in the same direction as change in momentum. Remember this, okay? Force is equal to change in momentum by time. So if you can calculate the direction of change in momentum, you can calculate the direction of force, which is what the question is asking. So let's calculate the direction of change in momentum. Change in momentum is nothing but final momentum minus initial momentum. So all you have to do is to subtract these two vectors, final minus initial. In other words, if I just say this is final and this is initial, I have to subtract these two, which means I have to just add these two. What I've done here is I've taken a negative of pi, initial momentum, and now I'm going to add these two and the addition will be what I want. Understood? How clever is that? Okay, once I add them, I can see that my resultant points in this direction, which is northeast direction. So the answer to this question would be northeast. How simple is that? All you have to remember is to find out the direction of change in momentum, and that is final minus initial. So you do final minus initial and you get your answer. Option 3. Chalo, move on. Okay, a theoretical question from Gauss's law. The question says integration over a surface of E dot ds is 0. First option says the number of flux lines entering the surface must be equal to the number of flux line leaving it. Sounds okay. Next, magnitude of electric field on the surface is constant. There are a lot of surfaces which have constant electric field. Okay, that doesn't mean that flux passing through them is 0. You can have a surface like this with electric field coming out of it at constant rate and the flux still wouldn't be 0. So, you know, this sounds a little shady. I don't want to risk it here. Next, all the charges must be necessarily inside the surface. Now, if the flux is 0, you know, if the flux is 0, Q inside is how much? Q inside is categorically 0. We know that. We know that from Gauss's law. Gauss's law tells me E dot ds, flux is 0. That means charge inside should also be 0. So that also is wrong. Next, the electric field inside the surface is necessarily uniform. It doesn't have to be, right? This E dot ds just has to be 0. It doesn't say anything about electric field having to be uniform. What does it mean to have 0 flux coming out of a surface? It means it has 0 charge inside it. Okay, if this is a closed surface, if this is the flux coming in, same amount of flux is going out. This surface does not have any generator of flux inside it. Who generates flux? Who is the source or a sink of flux? That's your charges, right? if there is flux coming in and out is same, that means there is no charge here, that means the surface must not have any flux. So this checks out. Option A checks out, and that should be the correct answer. Okay, a simple theoretical question. If you have read this theory, you should know the answer. Option number 1. Let's move on. Alright, next question talks about potential energy of a spring. So before moving forward, let's remind ourselves, what is the formula of potential energy of a spring? It is half kx square. Let's look at each and every term here. K, that's your spring constant. Then x, this is the elongation, the stretching of the spring. Okay, that is the formula for potential energy of a spring. Alright, so what does the question say then? Potential energy of a spring when stretched by 2 centimeters, okay, is U. When it was stretched by 2 centimeters, it had some U energy inside it. And when it was stretched by 8 centimeters, the potential energy became 2U, 4U, 8U, or something like that. Alright, so the question basically isn't asking me to actually calculate the potential energy, it's just asking me to compare. If I make my extension of the spring x 4 times, you see that? 4 times. What would happen to the potential energy? Think about it. If I put 4x here instead of x, instead of 2, if I put 8 here, or instead of x, if I put 4x here, what would happen? Half k 4x square. That's 16 times half kx square. Correct? 4 square is 16. So 16 times the initial energy is what you get when you stretch it 4 times. Let's move on. So a question from current electricity. I told you there will be a lot of these. So let's look at this one. If the galvanometer G, this one, does not show any deflection in the circuit, then the value of this resistance R, okay, this one. Alright, good question. There are 2 batteries here. So both of them are applying potential, and as a result of both of these, there is no deflection here. What do you mean by no deflection? What do you mean by that? When does a galvanometer show deflection, first of all, and when does it not show a deflection? By now, all of you must know this. Galvanometer doesn't show a deflection when there is no current through it. Okay? No current, no deflection. That means there is no current through this branch. Current here is 0. Very good. Now how can I find out the resistance? That's my question. Now I've used this information. How do I find this resistance? So to do that, what I need to do first is, let's assume the potential of lower points, these 3 points, to be same 0. Okay, you all know the potential method, right? We assume one common point, this is a common point, and we give it 0 potential. Now when you go from here, you go to the positive side of the battery. So you realize that you have gone to the positive side of the battery. That means you have added potential. How much? Okay, battery is 10, so 10. From here also, you have gone to the from negative to positive, so you have also added potential here. How much? 2. So you write 2 here. Now, resistance's job is to drop potential. Alright, resistance's job is to drop potential. But when does it drop potential? When current goes through it. Is there any current going through this galvanometer? Nope. So that means potential here and here should be same. Understand this? Let me repeat. If there is current flowing through a resistance, the resistance will drop some potential. Okay, that's the job. Okay. But if there is no current flowing, potential here and here will be same. In other words, potential difference will be 0. That's when current is 0, isn't it? Okay. So that means potential here and here is also 2. So now what I know is basically this part of the circuit has no current flowing through it. This has potential 2, this has potential 10, this is 400 ohms, and this is some R ohms. Let's do one thing. Let's find out this current flowing, this I. Okay, and this one's not 0, unlike this one. Okay, there is current in this one. Well, how do I know this? 10, 2. You can see that there is a potential drop. How does it drop? It drops by this resistance. So let's find out the potential dropped and then find out the current here. Potential dropped is equal to I into R. How much potential dropped here? 8, right? 10 minus 2, 8. is equal to I into 400. And from here I can find out the value of I. I becomes 8 by 400 or simply 1 by 50 ampere. Here's the master stroke now. This current comes in here. How much of it goes to the galvanometer? Tell me. 0. Correct? So all of it goes here, isn't it? All of this goes here. What's the potential difference here? Potential difference here is 2. So let's do it here. Potential difference here is 2 is equal to I into R. So 2 is equal to I into R. And from here I get the value of R very simply. That becomes 100 ohms. See how easy this is. Okay. Now it may look daunting at first, but this question was not very difficult. As long as you have done a little bit of practice of current electricity, this should not have been very difficult for you. 100 ohms. Let's move on. So the next question is about transformers. So this question is from AC. Alright. All of you remember transformers? Okay, let's solve this question. A 12 volt 60 watt lamp is connected to the secondary of a step down transformer. Alright, whose primary is connected to a AC mains of 200. So basically this is the primary. Potential here is 220 and this is the secondary, let's say. This has a lamp connected to it. Okay. Assuming the transformer is ideal. Ideal means there is no power loss. Then what is the current in the primary winding? Okay. So basically, power output here and the power input here should be equal. That's the condition for an ideal transformer. Power you feed is the power you get out. That's the ideal transformer's condition. So P input should be equal to P output. How much power is outputted here? You can see 60 watts. Alright, so put that here. How much is inputted here? Well, we don't know, but I think I can calculate using this formula VI. That's the formula for power, right? Here I'll put this as V, the primary winding voltage, 220 into I is equal to 60. And from there I can get the value of I, which should be 60 by 220, which is 3 by 11, very close to 0.3, slightly less than 0.3, isn't it? So that would be option number A. I don't even have to do this calculation because I just know 3 by 10 is 0.3, 3 by 11 should be a little less than 0.3, and that should be 0.27, option number 1. Okay, moving on. Alright, so the next question is a purely theoretical one, also from semiconductors this time. The question says, full wave rectifier consists of 2 PN junction diodes, okay, and a center tap transformer. That's what usually you have. There's a capacitor and a load resistance connected. Okay, that's a general idea of a full wave rectifier, isn't it? Which of these components removes the AC ripple from the rectified output? Ripple, or that crest and trough that you see. Who removes that? Well, this is a theoretical question. Capacitor does. Okay, the capacitor's job it is to flatten out that curve, isn't it? So the answer for this question should be capacitor. Simple enough. Alright, if you have read the chapter before, you should know the answer for this question. Moving on. Alright, let's look at this question. This question is from ray optics. Let's see what the question says. Light travels a distance of x in time t1 in air and then 10x in t2 in another denser medium. Okay, good. What is the critical angle for this medium? Now some of you might already directly know the formula of critical angle or what critical angle is, but if you don't know, follow me. This is the normal, this is the boundary of two surfaces. One of the surface, the rarer surface, is air, so it's mu is 1, and the densest surface here is some kind of mu. This is the denser surface. Alright. Now light enters in like this at critical angle. Well, you know, when it's going to a rarer medium, it should diverge out, it should increase your angle. At a certain angle like this, at a certain critical angle, it diverges so much that it actually goes flat like this, parallel to the boundary of surface. Okay, this kind of a motion of a light is called as the critical case of refraction, and this angle of incidence is called as the critical angle. Okay, so how do we find this angle? We use Snell's law. Let's use Snell's law. Snell's law says sin I by sin r, or mu sin I is equal to mu sin r. So let's say mu sin I should be equal to mu of air sin of r. Right? Clear? What is r here? This is the r here. Measured from the normal, r is actually 90 degree for a critical refraction. So basically this is sin 90 degree. Sin 90 degree is 1. So I get 1 on the other side, and I can just look at the formula of sin IC, which some of you might be groaning by now. Oh, I remember this formula, it's 1 by mu. Yes, yes it is. But even if you don't remember, you see how much effort it takes to calculate it, to derive it, right? Not a lot. As long as you know what critical case is, you are okay to just forget about the formula and derive it whenever you need it. But I suggest remember the formula. Okay, so now that we know the formula, we somehow need to find this angle in terms of this mu. So we need to first find the mu. How do you do that? Look at the question. The question gives you distance and time, then some other distance and some other time. What is that indicating? It's indicating that something about speed is going to happen here, right? So basically, I want to relate the speed of light in air to speed of light in this medium. How do I do that? There is a simple formula for that. And what's the formula? Some of you might again already remember this formula. Mu is c by v, where c is the speed of light in air by speed of light in medium. This ratio is called as refractive index. This is another definition of refractive index. You must remember this one as well. Okay. So what is the speed of light in air? Don't give me the value. Don't give me 3 into 10 to the power 8. Just look at the question, look at the context in the question. It says x distance in t1 time in air. So again, I ask again, what is the speed of light in air? It is traveling x distance in t1 time. So that's the speed, x by t1. Next, velocity in the medium. Now I don't need to repeat myself, 10x by t2, isn't it? Okay, so this x cancels out, t2 goes in the numerator, t1 comes out in the denominator, and I get t2 by 10 t1 here. Very good. So mu comes out to be t2 by 10 t1, which means 1 by mu comes out to be how much? 10 t1 by t2. Why do I do this? Because I know 1 by mu is just sine IC. I just derived it. So I get the value of sine of critical angle, which is 10 t1 by t2. In other words, critical angle IC just comes out to be sine inverse of 10 t1 by t2. Chalo, let's look at the options. 10 t1 by t2, where do I see this? 10 t1 by t2, that's option number 4. That should be the correct answer, isn't it? 10 t1 by t2. Simple question. Okay, let's move on to the next one. Let's look at the simple question from carbon coding of resistances. Let's see what the question says. Resistance of a carbon resistor is determined from color codes is to be 22,000 plus or minus 5%. The color of the third band must be. So basically what this question is telling you is, I looked at a resistance, it looks a little bit like this. There are 3 bands here, and then there is a 4th band here, or it may not be there. Okay, you know what these 2 bands do, right? You have studied color coding of carbon resistances. You know what these bands do. This one, these 2 are for the first 2 digits of resistance. First 2 digits of the value of resistance. The third one is the multiplier. Now this one talks about 10 to the power how much is the resistance, okay? And the 4th and last one, if it is present, talks about the tolerances in the values of resistance. Okay, so the first two digits should give you the first two digits 22. Next should give you the 10 to the power multiplier. Now how much you have to multiply to get 22,000? You have to do it 3 times, right? So basically 22 into 10 to the power 3 plus or minus 5%. This is what your resistance is. This is what corresponds to this one. Multiplier is number 3. And if you check the list of color codes, you'll find that on the order of number 3, the color that you get is orange. So the answer here should be orange. Alright? Okay, let's move on. Next question. Next question says, photovoltaic devices, they can convert optical radiations into electricity. Yes, that's what they do. Zener diode is designed to operate under reverse bias in breakdown region. Yes, also the work of a Zener diode. Zener diode's job it is to operate voltage. So if a voltage crosses or changes direction, that's when it operates in breakdown region and it goes in reverse bias. Reverse bias basically means that it shuts itself off. Okay, so this statement is also correct. So statement 1 and 2 are correct, 1 and 2 are incorrect. 1 is correct but statement 2 is incorrect, or 1 is incorrect and statement 2 is correct. Both are correct, isn't it? This should be a simple enough one. Photovoltaic devices. Photo to voltaic. Optical radiations to current. So that's also right. And Zener diode, its job it is to operate in reverse bias when it goes into breakdown region. Okay, so that's also correct. Moving on. Magnetic energy stored in an inductor of inductance L is equal to 4 microhenry carrying a current of I is equal to 2 ampere is how much? Now this is a simple formula based question. The formula for magnetic energy stored inside an inductor is half Li square. For all of you who have revised your EMIs and ACs, you must remember this formula. It comes in again and again in these two chapters. Okay, if you remember this, then it's all about just putting the formulas. This is 4 microhenry, so micro 10 to the power minus 6 Henry, don't forget that, into 2 square, I square. So that's 4 into 4, 16 by 2, 8 into 10 to the power minus 6, which is basically 8 microjoules. And that should be your answer. Option number 4. Simple. Let's move on. Alright. So the next question from mechanics. Angular acceleration of a body. Angular acceleration L of a body moving along a circumference of a circle is. Basically, a body is performing circular motion. Long, short way of saying a body is performing circular motion. Where is the angular acceleration? Okay. Angular acceleration L has a formula R cross P. You must remember this formula. Right? If this is the R, this is the radius vector, and for someone who is performing a rotation like this, value of velocity will be in this direction, right? So velocity is in the same direction as momentum. Momentum is, after all, mass into velocity. So whatever is the direction of velocity will also be the direction of momentum. So this is R, this is P. You want R cross P's direction. Where would it be? Take your right hand, align it in the direction of R, then move your fingers towards P. That gives you the direction of R cross P. So it's in this direction, basically in this direction. Understood? What's that direction? That direction is at the center, but along the axis of rotation, basically perpendicular to the plane, along the axis of rotation. This particle is rotating like this, axis of rotation is here. This is the direction of angular momentum. Angular momentum for a circular motion will always be in the direction of axis of rotation. Okay, so that should be the answer. Simple enough theoretical question. If you have revised your angular momentum, you should have remembered this. Let's move on. A Carnot engine has an efficiency of 50%. So efficiency eta is given as 50%. Source temperature is given as 327 degrees Celsius. Then the temperature of sink is the less one, source is the bigger one. Okay, it goes from source to sink, a little bit of output, correct? And the formula of efficiency is 1 minus sink by source. Okay, you want something that is smaller than 1 to be subtracted from here. So 1 minus T2 by T1. You think like that. This should be the sink, this should be the source. Now remember, in the formula for Carnot engine's efficiency, the value T2 and T1, these are all in Kelvin. Everything is in Kelvin. Okay, so we need to convert these values first into Kelvin. So let's do that. Then we can calculate efficiency. This 1 minus T2 by T1 should be how much? 50%, as in the ratio should be how much? 50% is 1 by 2. So this should actually just be equal to 1 by 2. Okay, so let's do it. From here I can just see T2 by T1 should be 1 minus 1 by 2, which is 1 by 2. In other words, T1 should be 2 times T2. How much is T1 then? 327 degrees Celsius. 327 plus 273, that will be in Kelvin. 7 plus 3, 0 carries over 1, 0 carries over 1, 600 Kelvin. So I get 600 over here should be equal to 2 times T2. Basically, T2 comes out to be 300 Kelvin. Check the options. What? It's not matching? Yes, of course. Answers are in degree Celsius, not in Kelvin. Convert that again to degree Celsius. How do you do that? Subtract 273 from it. That will be 7, 2, and that's all. 27. That should be the answer. 27 degrees. See how simple this is? Alright, let's move on. Let's look at a simple question from gravitation here. What does the question say? There are two bodies, mass m and 9m, and they are placed at a distance r from each other. Simple question. Gravitational potential on the line joining these two bodies, where the gravitational field should be equal to 0. Basically, these two bodies, m and 9m, distance between them is r. Somewhere on this line, gravitational field will be 0. Find out that point and find out potential of that point. Understood the assignment? Let's do it. Somewhere here, somewhere along the line, gravitational field must be 0, somewhere here. Let's call that distance x, where the gravitational field is 0. So what is basically happening here? How is gravitational field becoming 0? One's gravitational field is balancing the other person's gravitational field. Okay, so these gravitational fields are cancelling out and they are becoming 0. If this distance is x, this is r minus x. That's clear. Let's balance the fields. G m by x square. Gravitational field due to m is g m by x square. Now that should be equal in value, opposite in direction, so that it cancels out. So in value it should be equal to g into 9m by r minus x square. Understood what we did here? Mass, distance of the mass from the point of balance. Mass, distance of the mass from the point of balance. Simple. From here, I can cancel a few things from here. G, very good. M, very good. Always happy when that happens. R minus x whole square should be equal to 9x square. In other words, r minus x should be equal to 3x. R is equal to 4x, or in other words, x is r by 4. So what I'm trying to say is this distance, guys, is r by 4, and this then is 3r by 4, isn't it? If the total is r, this is r by 4, the other one should be 3r by 4. Simple enough. Okay, so now you want to calculate potential of this point. Now that's simple enough. Potential just add up. They are scalar quantities. They're not like vectors. They're not like fields. Okay, you don't have to cancel them. You just add them like it is. And what is the formula for gravitational potential? The formula is G minus, with a minus sign, m by r square. That's the formula. Okay, if you have m mass, gm by r, that's the formula of potential. If you have m mass and at a distance r, the potential due to that mass there will be gm by r minus. So v net will be v1 plus v2, v due to m mass, and then v due to 9m mass. Let's draw the diagram here again quickly. Let's say we haven't forgotten anything here. R by 4, this is the distance, and this distance is 3r by 4. Okay, good. Potential needs to be calculated here. This is m, this is 9m. So let's add these potentials. Minus g, mass of m, distance of r by 4 minus, because potential is always negative for masses, g 9m mass here at a distance 3r by 4 you are calculating the field. Okay, good. So this becomes minus gm by r, 4 here goes in the numerator, and this cancels here 3, this goes up and this becomes minus 12 gm by r. Minus 12 minus 4 minus 16 gm by r. That should be my answer. Let's check if I am correct. Minus 16 gm by r is in the option, and it's option number 3. That should be the correct answer. Let's move on. A vehicle travels half the distance with v and the other half, of course, remaining with 2v. What is its average speed? All of you have done 11th standard properly should remember the formula of average speed when the distances is constant. What is the average? What is v average when distances are constant? When you travel equal amount of distance in unequal amount of times, the formula of average velocity is 2v1 v2 by v1 plus v2. Don't believe me? Go and check it. Okay. So put the values here. 2v by v plus 2v. This is 4v square on the top, and in the bottom we have v plus 2v, 3v. So what I get essentially is 4 by 3v, which should be the answer, which is option number 3. That's the correct answer. How simple is that? Alright, so the next question comes from surface tension. Let's see what the question says. The amount of energy required to form a soap bubble, radius of soap bubble is given, and soap solution having a surface tension of 0.03 Newton meter. So first of all, energy to form one surface is T into A, tension into the area along which the tension is acting. Okay. When you make a bubble, understand that you are making two surfaces. What do you mean by two surfaces, sir? Well, bubble is not completely filled inside, right? You have your one surface here, the outside surface. You need some surface tension, so you need some energy to build that up, and then you need some surface energy here as well to build this inner surface inside the bubble. So you have essentially two surfaces here. So 2 times T into A, because area becomes twice. It's a very thin bubble. Yeah, okay. Inside and outside the bubble have same area. So I can just say 2TA, and that's the logic of why there is a 2 in this formula. Some of you might be remembering the formula, but you might have been confused. Why there is a 2? Why there is a 4? That's the answer. Okay. So let's put the values. 2 surface tension value is given 0.03. Let's put that value here. Area's value is not given, but radius is given. That essentially just means area is given. For a sphere, what is the surface area? 4 pi r square. So let's write that here. 4 pi r is 2 centimeters. So 2 centimeters. So let's convert that into meters. 2 into 10 to the power minus 2 square. Okay. Let's see what happens. 2 into 0.03 into 4 pi into 4 into 10 to the power minus 4. Just looks complicated. It's not. Alright. 2 into 4, 8. 8 into 4? 8 into 4? 32. 32 into 0.03 into pi into 10 to the power minus 4. Okay, let's do this calculation. 32 into 3. Do it with me, okay? No calculators, no cheating. Am I right? 96? Let's write 96 here. 1, 2, 1, 2 zeros into pi into 10 to the power minus 4. Good. Now how do I do this multiplication? Pi is almost 3, 3.14, 3. This is almost 1. 3 into 1 should be very close to 1. Oh, sorry, 3 into 1 should be very close to 3 point something something. So that should be the answer. 3 point something something into 10 to the power minus 4. That should be the answer. Option number 3. See, calculations, they're not difficult. What you need to understand, you just need to have a little bit of understanding of what's happening. This is very close to 1. That's very close to 3. Product of those two will be very close to 3. And that should be your answer, option number 3. Let's go. Minimum wavelength of X-rays produced by an electron accelerated through the potential difference V is proportional to. Now, EV is the energy that is given to an electron when it's accelerated by V potential. And wavelength corresponding to that kind of an energy, wavelength corresponding to energy of matter, is given by hc by lambda, right? So you see wavelength is inversely proportional to V, alright? So wavelength is inversely proportional to V. That's your answer, that's the answer. Alright, a simple question from radioactivity. You might be thinking this is a complicated question. You know, some of you find this difficult, I know this. But don't worry about it. Let's see how we can solve this question without even touching the board. Okay? Alright, read the question with me. Let's go. The half-life of a radioactive substance is 20 minutes. In how much time the substance's activity drops to 1/16th of its initial level? Like I said, without touching the board. We can do this without touching the board. Let's see how we do it. Half-life of a substance is 20 minutes. In other words, take one sample of a substance. In 20 minutes, half of it is gone. How much is left? Half. Of that other half, in the next 20 more minutes, another half of it is gone. So half, in the next 20 minutes, another half is gone. Basically, in 40 minutes, you are left with 1/4 of the sample. Okay? Wait 20 minutes more. Now that makes the clock to 1 hour, 60 minutes. And in 60 minutes, 1/2, 1/4 has become now 1/8. Understood? Okay, this is how half-life works. You take a sample, half-life is a minute, let's say. Within a minute, half of it is gone. Within 2 minutes, 1/4 is gone. Within 3 minutes, 1/8 is gone. 1/8 is left. Okay, understood? So let's see. 1/16th is what is left now. That's the activity. So how many half-life cycles must have been done? I think you can see this now. 1 by 2 to the power something. Correct? Let's see. 1 in 20 minutes, half. In next 20 minutes, 1 by 4, 1 by 2 into 1 by 2. In the next 20 minutes, multiply that again by 1 by 2, 1 by 8. In the next 20 minutes, multiply that again by 1 by 2, 1 by 16. So the answer should be 4 life cycles, 4 half-life cycles. That's when the product drops to 1/16th of its original activity. So basically 4 life cycles, 4 half cycles happen. That is 4 times this, which is 80. Basically 1 by 2 in the first cycle, 1 by 2, that's reduced it to 1 by 4, 1 by 2 again, that's reduced it to 1 by 8, and 1 by 2 again, that's reduced it to 1 by 16th. How many cycles? 4. So time taken is 4 half cycles, which is 80 minutes. I told you, this was not a difficult question. Okay, let's move on. Let's look at this question from errors and analysis. Now this part has been deleted from the NEET syllabus these days, but the question was asked last year because it was in the syllabus last year, so let's look at the question. Okay, a metal wire has some mass, some radius and some length. They're asking you, what's the maximum error you can have in the measurement of its density, given that these are the errors in mass, length and radius respectively. Given that these are the errors you have, what will be the error in a dependent quantity like density, for example? What's density? What's the formula of density? Density is mass by volume. So basically in this context it will be mass by area into length. That's what it is. In this context, volume is area into length. Because I know area, how do I know area? Once I know radius, I know area. Area is pi r square for a radius. So mass by pi r square L. This is what my density is. Now if I talk about the dimensional analysis, if I talk about the error analysis of this, what do? Delta rho by rho should be equal to, measure the powers. What is the power of m? Power of m is 1. So delta m by m should be the error contributed by masses error, plus what is the power of r? R's power is 2. So the error contributed should be 2 times the error in radius. See, it's power 2, so 2 times that. Next, what's the power of L here? 1. So the error contributed should be 1 time delta L by L. That's how errors are contributed. You all should remember this. If you attended your physics labs, they might have taught you there itself. Otherwise, they might have taught you in the class. Okay. So let's put the values. Delta M 0.02. 0.002, my bad, divided by mass 0.4 plus 2 times, what's the error in radius? 0.01. So let's plug that value here, 0.001 actually, divided by, what's the value of radius actually? 0.3. So let's put that here as well, plus length. Now length's error is 0.02, so let's write that here, and then divided by 5. Now it's a tricky calculation, a little bit complications. You can do this. When you do the calculation, the answer comes out to be 0.015 and some 6, something like that. Okay, not a genius, I've done this before, that's how I know. Okay, so that's the absolute error you have, the fractional error. You want the answer in percentages, right? So you have to multiply this by 100 to get the error in percentages. And basically the answer that comes out is 1.56 approximately percent. In other words, that is 1.6% roughly. And that's your answer. Okay, let's move on. Alright, question number 22 says, in a plane of EM wave, so this is a question of EM wave, I can clearly see that. It's traveling in free space. Okay, good, that's important information. Value of electric field's component has a frequency this much and the amplitude this much, and the amplitude of oscillating magnetic field is. So this question is quite tricky. This question actually gives you information you don't need. What do I mean by that? You know that this c value, speed of light, is actually E naught by B naught, correct? You know this is true for any EM wave traveling in space, correct? So you need E naught, you need C, and from there you can calculate B naught. This is the amplitude of electric part of the wave, this is the amplitude of magnetic part of the wave. You take the ratio, you get the speed of light. There's an information here that you don't really need, but that's been given, who cares? We don't need that. So let's get the value of B naught then. B naught will simply be E naught by C. Put the values, amplitude is 48, let's divide that by C, that's 3 into 10 to the power 8. Now if I do that, this will just be 1 goes here, and you get 16 into 10 to the power minus 8, or 1.6 into 10 to the power minus 7, and that should be the correct answer, isn't it? Right? One power goes here and one power gets reduced. There you go, that's the answer of the question. How simple is that? Useless information, they might give you redundant information like this just to confuse you. Don't be afraid. Okay, you know the formulas, you know the method, you can get your answers. Alright, next question says, temperature of a gas is minus 50 degrees Celsius. To what temperature should the gas be heated so the RMS speed of the gas is increased by 3 times? Okay, how is the speed dependent for a gas? How is speed dependent to its temperature? You know the formula for speed of gas and the temperature of the gas, right? RMS speed is basically root of 3 RT by M, isn't it? So what's the relation here? The relation is that of square root, like this. So if I were to talk about V1 by V2, that in terms of temperature should be T1 by T2. Okay. Now in this case, in this context, initially my speed was V, RMS speed was V. Finally, what was it? Increased by 3 times. It was increased by 3 times. Basically, what do you mean by that? It became 4V. Increase is 3 times. So the actual value, final value will be 4V. This is where you get, okay? You need to remember this. You need to pay attention to what the question is saying. It says increased by 3 times, so that's 4V, okay? So let's write that here. V by 4V should be equal to root of T1. What's T1? Minus 50 degrees Celsius, in other words, in Kelvin, that is 273 minus 50, or 223 Kelvin. Okay, so let's write that here, 223 by T2. Cancel this out. What do you get is T2, square this out, you get T2 is equal to 16 times 223. Okay, and whatever is the answer, in Kelvin, subtract 273 from it, and you should get the answer in degrees Celsius, or basically the value in Kelvin. So let's do this multiplication. 223 into 16, 3568 Kelvin. 3568 Kelvin does not match. What if I subtracted 273 from it? If the answer is in degrees Celsius, I don't know. Let's see. 5, 0, 2, 3. 3, 2. I think this is the answer. Okay. There might be a mistake in calculations here and there, but that's okay. Option number 2 should be the correct answer. As long as you do this correctly, you should get this answer. The logic here is very simple. You have to find out V by root T. Understood? Okay. Let's move on. All right. Let's look at this question. This question is from AC. What does it tell you? An AC source is connected to a capacitor. Due to decrease in its operating frequency, what happens to the reactance of the capacitor? Reactance of the capacitor. What is the reactance? 1 by omega C. Now for a capacitor, decrease in the operating frequency is what has happened. In other words, operating frequency 1 by 2 pi f C. This has reduced. Frequency has reduced. Has the C changed? No, you can't do that. Unless you physically change the capacitor, you cannot change its capacitance, right? You have to do something physical to change that. So if you reduce frequency, reactance should automatically increase. There you go. Reactance increases. Now if the reactant increases, displacement current should also decrease. So option number 3 should be the correct answer. Let's move on. Alright, last question for today. This question's from Young's double slit experiment. So this is your wave optics. Let's see what the question says. Young's double slit experiment. There are 2 statements given here. Now the question talk about angular width. Okay, angular separation of fringes. Let's see. What is the angular width formula? Angular width formula is lambda by d. Beta is lambda by d. Okay. If the screen is moved away, angular separation remains constant. Yes, it does. It does not depend on the screen distance. What does it depend on? Wavelength of the light you project and the distance between the slits. Not on the screen, just on the distance between the slits. So yes, this remains constant. This is correct. If a monochromatic source is replaced by another monochromatic source of larger wavelength, angular separation decreases. So what you're trying to tell me is, if I increase this lambda, this should decrease. What? That doesn't make any sense. If I increase this, this should also increase. There you go. So statement 1 is correct. Statement 2 is false. That should be my answer. Statement 1 is true. Statement 2 is false. Option number 3 is the correct answer. And that's that. Okay. We'll discuss the next 25 questions in the coming video. So if you want to watch that as well, subscribe to stay updated to our channel.